Hello, welcome back to the channel. We're going over some publicly available FRQ questions for AP Physics 1. This particular one has to do with work, springs, and oscillations. As you can see in the diagram, we have a 20 kilogram object and it's moving at 4 meters per second to the right, approaching an unstretched and uncompressed spring. So just spring is chilling there. We don't know its K. That block is going to bump into that spring, attach itself, I guess there's Velcro or whatever, and it's going to start oscillating. Before it goes into full oscillation, it will compress the spring to 0.5 meters. It had kinetic energy because it was moving. When it compresses it to this much, what energy are we talking about? Elastic potential energy. If there is no friction, all the kinetic energy initial is going to be equal to potential energy of the spring. And then oscillation starts and we go from maximum displacement, maximum force, maximum acceleration to when it gets back to this position right here where the spring is unstretched, we're going to have maximum kinetic energy. Just like think about the moment it attaches itself, it still has its maximum kinetic energy, and then back and forth it goes. And we have a number of questions right here, including creating some graphs, a graph for kinetic energy, a graph for acceleration. Shall we? Question A, AI, just to determine is the work done by spring positive, negative, or zero. We started with kinetic energy, and remember work net, and in this case the only thing that is doing work is the spring. Work net equals change in kinetic energy. What's happening with kinetic energy? It drops. So this right here is less than zero, so therefore the work is negative. And then in AI, they need us to actually calculate it. Well, it's going to be equal to the change in kinetic energy. Kinetic energy being 20 over 2 times 16, which is 4 squared. So that's going to be 160 joules. That is the amount of work, negative work, right? So work of the spring is going to be negative 160 joules. Question B, they want us to figure out K. Since kinetic energy equals elastic energy and they give us x, kx squared over 2 equals mv squared over 2. 2's go away, so therefore k is going to be mv squared over x squared. So we can do 20 times 16 over 0.25. So it's 16 times 4 because you're dividing by 0.25. This is like, what is 0.25 is 1/4, right? So this is like dividing by 1/4, which means that you're multiplying by 4. 16 times 4 is 64. So we are ending up with 20 times 64. 2 times 6 is 12. 20, 60, that's 2 zeros. And then 20 times 4, that's 80. 1280 newtons per meter. And that is technically 3 sig figs, but that's all right. Now, maximum acceleration. When do we have maximum acceleration? We have maximum acceleration when we have maximum displacement. So at the moment when all that spring was compressed, we ended up with maximum acceleration. Where's that acceleration coming from? From the force of the spring. Remember, force of the spring, according to, this is an ideal spring, it obeys Hooke's law. Negative kx, where negative stands for just the direction. And then F equals mass times acceleration, because that's the only force acting on our object, no friction. Well, gravity and normal balance each other out vertically, but horizontally, that's the only force. Acceleration is going to be kx to m, so 1280 times 0.5 divided by 20. All right, so it's like 1280 divided by 40. That's 32 meters per second squared. All right, look at us go. We are at D already. Frequency of oscillation. Remember, frequency is 1 divided by t. Period for oscillation of mass on spring is 2 pi root m to k. So then what is frequency? It's a reciprocal of that. So that's going to be root of k to m divided by 2 pi. 1280 over 20, that's 64. Root of 64 is 8. So it's going to be 8 and over 2 pi. So it's just 4 to pi. That's 1.27 hertz. There we are. 1.27 hertz is the answer to frequency of the oscillation. He's asking us to draw 2 graphs. The first one is graph for kinetic energy. Remember, at 0 is going to be maximum, at 0.5 and negative 0.5 is going to be minimum. And because remember we have kx squared over 2 equals mv squared over 2, this is proportional to x squared. So it's going to be a parabola. Boom, 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 boom. Something like that. That's an awful parabola. You can do better, I am sure. And then finally, this. Remember, acceleration is force divided by mass, and that is kx over m. And also, because the restoring force is opposite in direction, where we have maximum positive direction, we have negative acceleration, and where we have maximum negative displacement, we have a positive acceleration. So something like this. There you go. And that answers the last question for this beautiful example of a mass on a spring. If you have any questions, put them in the comments below. If this was helpful, please like, subscribe, and share. Be kind.